All right, today we're going to be looking at solving quadratic equations using completing the square. Completing the square is as much effort, I think, as quadratic formula, but it is one of those things that you can use, like quadratic formula, to solve any and all quadratic equations. So the step one, and you'll want to write these down, and then I'm going to do it as an example. Much easier when you're doing the example than from the words. Isolate the x squared and x terms by themselves on one side of the equal sign. Step two, divide both sides by the coefficient of the x squared term. So everything on both sides gets divided by whatever the coefficient of the x squared term is, because we want the x squared term to have a positive 1 coefficient. Step three, add half the absolute value of the coefficient of the x term squared to both sides. You'll see what I mean by that shortly. And step four, complete the square. I'll show you how that works. And step five, solve. So here's our first problem, solved by completing the square. So the first step in this process is to not get everything on one side equal to 0. Instead, it's to isolate the variable squared and the variable terms. Now I had x and x squared, w and w squared in this case. So I'm going to subtract 1 from both sides. Now watch this, 4w squared plus 4w equals 74. I need to get rid of this 4 with w squared, so I have to divide everything on both sides by the coefficient of the w squared term in this case. So that gets me w squared plus 4w, I'm going to leave a gap here, equals 74 over 4. I'm actually going to leave it that way and not reduce it first. And there's a reason for that, you'll see in a minute. I made a mistake already. This should be w. All right, so now, step three, add half. So I'm going to add something squared to both sides. That's the first thing. I'm going to add half of the coefficient of the w, or variable to the first power term. Half of 1 is 1/2. I'm going to add half squared to both sides in this case. Now, here is the complete the square part. So I need to write this side as a binomial squared. So the first thing, the thing being squared here is w, so that goes in the beginning of each parenthesis. The sign of the middle term is what is going to be used between these two, and the thing being squared here is going to go at the end. So the w goes here, the sign of the middle term goes here, and the thing being squared goes here. That's where those three things come from. And on the other side, I get, let's see, 74 over 4 plus 1/2 squared. I square the top and the bottom, 1 over 4. So that gives me 75 over 4. Now, if you recall, now I'm just going to rewrite this. Just to make it a little easier for us to work with. There's no good requirement to have to rewrite that. In fact, normally I would do it here, but these lines are getting in the way. I'm going to square root both sides to get rid of the squaring. This is so I can solve. So I square root both sides. Remember, we said whenever we square root both sides, we have to include the plus minus sign. So the square root and the square cancel. W plus 1/2 equals, I have to include the plus minus sign. And then remember when we worked with the square root of a fraction? We have to square root the top and the bottom separately. The square root of 4 is 2. That's why I didn't reduce it. And the square root of 75 is 5 square root of 3. Now, if you don't remember, 5 times 15, and 15 is 5 times 3. I have a pair of 5s, that's there, and the 3 is left inside. The last step I have to do is move the 2 over, so I subtract a half from both sides. So I end up with W equals negative 1/2 plus minus 5 square root of 3 over 2. Now, in the quadratic formula, you'd have written this as negative 1 plus minus 5 square root of 3 over 2, like that. These two are equivalent expressions. Either one is an acceptable answer. So that's how you would see this with the quadratic formula. This is what it's going to look like in the complete the square. All right, so the next question is, having just done that, what would C have to be for this trinomial to be considered a perfect square trinomial? Well, we would need C to be, remember we just added half of the coefficient squared? Absolute value, remember? So C would have to equal something squared, and that something squared is half of 5. So half of 5, because we're cutting this coefficient in half, but we're not including its sign. And we know that would equal 25 over 4. That's what C would have to equal for this to be a perfect square trinomial. So here's our next example. Step 1 is not to have everything equal 0, it's to get the x squared and x terms by themselves by subtracting 100 from both sides. X squared plus 18x, big space, equals negative 100. I do not have a coefficient other than positive 1 in my x squared, so I am adding something squared here and here. And the thing that I'm adding squared is half of this coefficient. Well, half of 18 is 9, not 9 over 2, but 9. And so when I write this out as something squared, it's going to be x, sign of the middle term plus the number 9 being squared. And on the other side, we know 9 squared is 81. 81 minus or plus negative 100 would be negative 19. Now I need to solve. I'm going to complete square root both sides. This is completing the square. X plus 9 equals plus minus I square root 19. Remember, pull the negative out as an I. And we finish this off by subtracting 9 from both sides. X is negative 9 plus minus I square root 19. And there you have it. That is all there is to it. Next example. I already have everything on one side, the w squared and the w terms isolated. I need to get rid of that 4. I'm dividing everything on both sides by 4. W squared equals, minus 3w, big space, equals, now I can actually do that because it goes in evenly 6 times. So I've divided by the coefficient of the w squared term. Now this is a 1, so I need to add something squared to both both sides. That something is half the absolute value of this. So to make it in half, I put it over 2. So W, the sign of the middle term is negative. The thing being squared there is 3/2. 3/2 squared is 9 over 4. And if I want 6 as a fraction with 4 as the denominator so I can combine them, 6 times 4, 24 over 6 is equal to 6. I add these two. That'll give me 33 over 4. So now I'm going to square root both sides. W minus 3/2 equals plus minus. Now I can't square root 33, but I can square root 4. And now I'm going to add 3/2 to both sides. W equals 3/2 plus minus the square root of 33 over the number 2. And I'm all done. Next one. Try it yourself, see what you can do. Unpause when you're done. We're going to add 40. X squared minus 4x, give yourself the gap, equals 45. Add something squared. Well, what am I adding squared? I'm going to add half of 4, which is 2, being squared. So to complete the square, that's going to be the x, the sign of the middle term, the thing being squared. Over here, 2 squared is 4, plus 45 is 49. And then I'm going to square root both sides for solving. X minus 2 equals plus minus, well, square root of 49 is 7. And then I add 2 to both sides. X equals 2 plus minus 7. Well, we can actually get an answer here. 2 plus 7 is 9. 2 minus 7 is negative 5. And those are my two answers, 9 or negative 5. And I think this is the last one, but I could be wrong. I'm going to move that over. Well, of course, you're going to do this by yourself. Add 10. 6x squared plus 11x equals 10. And unpause when you do it the rest of the way yourself. Divide everything by 6. And this is tricky. How do you cut 11 over 6 in half? Well, you double the denominator. Because if you multiply by 1/2, that's cutting something in half. So 1 times 11, 2 times 6, 11 over 12. So x plus 11 over 12 equals, now we get a little work here, 121 over 144. I have to make this into 144 for a denominator. What do I have to multiply times 6 to get 144? That's high. Let's see. Well, 12 times 12. So 6 times 24, so 240, 24 times 10. So now I've got 361 over 144. double check all my calculations because it's awful to get it wrong. Let's see. That is right. And 240 plus 121. Yep, I do have it right. Oh, that's interesting. So I square root both sides. X plus 11 over 12 equals plus minus. It turns out that 361 is square rooted is 19. And of course 144 square rooted is 12. Yep, just double checking. So then when I subtract 11 12s from both sides, you end up with x equals negative 11 over 12 plus minus 19 over 12. Now I can write them separately. Negative 11 plus 19 over 12. Negative 11 minus 19 over 12. Let's see. 8 over 12, or let's see, 2/3. Here, it's going to be negative 30 over 12, and 6, so negative 5/2. Those are two answers. And that was our last problem. So, good luck with those. Have a great day.